This problem is from the 2004 summer, paper 1, for the maths exam, and it was problem 11. The roots of the equation x cubed minus x minus 1 equals 0 are alpha, beta, and gamma, and we have our usual definition of Sn as alpha to the n plus beta to the n plus gamma to the n. And then part I asks us to use the relation y equals x squared to show that alpha squared, beta squared, and gamma squared are the roots of the equation y cubed minus 2y squared plus y minus 1 equals 0. No problem there, it's a square root substitution, and we practiced how to do that before. Just bring all the odd powers of the variable to one side, so that will be x to the power 3 minus x, and bring all the even powers of the variable to the other side, so that will be the 1 times x to the power 0, which is an even power. Alright, and then from here we can square both sides, and then that gives us x to the power of 6 minus 2 times x to the power of 4 plus x squared equals 1. And then we can obviously bring the 1 to the other side. So minus 1 equals 0. And then we can go ahead and make our substitution y equals x squared. So that gives us y cubed minus 2y squared plus y minus 1 equals 0, which is exactly what we got down here. Part II says hence or otherwise find the value of S4. Well, S4 is the sum of alpha to the 4, beta to the 4, and gamma to the 4, using this formula there. So from this equation here, we can see that alpha squared plus beta squared plus gamma squared is equal to negative 2, which is 2. So alpha squared plus beta squared plus gamma squared equals 2. And we also can find that the sum of alpha squared, beta squared is equal to 1. So we could do this using algebra. The sum of alpha squared will be equal to S4 plus 2 times the sum of alpha squared, beta squared. So that's fairly easy. Sorry, my mistake, I wrote S4 wrong there. Fix that. Alright, and then just quickly finishing that off, because since we got that far, sum of alpha squared is 2, so 2 squared is equal to S4 plus 2 times 1. And then from there we get S4 is equal to 2. So that's one way to do it fairly quickly. But since later on we're going to be asked to find S8, S12, and S16, let's do it in a different way. Let's go ahead and find the polynomial where alpha to the 4, beta to the 4, and gamma to the 4 are the roots. And we can do it just by doing exactly what we did in the first step. Substitution of this form to this polynomial. Alright, so bring all the odd powers of y to one side, so y cubed plus y, and then bring all the even powers of y to the other side, so that'll be 2y squared plus 1. And then we're going to square both sides of it, and that gives us y to the power of 6 plus 2y to the power of 4 plus y squared is equal to 4y to the power of 4 plus 4y squared plus 1. And then from there, y to the power of 6 minus 2y to the 4 minus 3y squared minus 1 equals 0. And make a substitution, say w equals y squared, then we get w cubed minus 2w squared minus 3w minus 1 equals 0. And because of this substitution that we made, and the roots of the original cubic equation were alpha squared, beta squared, and gamma squared, this cubic equation has roots alpha to the 4, beta to the 4, and gamma to the 4. And so we can immediately see that S4, which is the sum of these roots, is equal to negative negative 2, which is equal to 2. Okay, for part III, we're asked to find S8, S12, and S16. And this equation here with these roots, I feel is going to come in pretty handy, so let's put a circle around that. Now to find S8 and S16, we can just do exactly what we just did here. So bring all the even powers of w to one side and the odd powers to the other side. So w cubed minus 3w is equal to 2w squared plus 1. And then square both sides. Alright, so we get w to the power of 6 minus 6w to the 4. And then plus 9w squared is equal to 4w to the 4 plus 4w squared plus 1. And then rearranging w to the 6 minus 10w to the 4 plus 5w squared minus 1 equals 0. And then we'll make a substitution, choose another letter, z. Z equals w squared. So we get z cubed minus 10z squared plus 5z minus 1 equals 0. And this one has roots alpha to the 8, beta to the 8, and gamma to the 8. And so immediately we can see that S8, which is the sum of these roots, is equal to negative negative 10, which is positive 10. And we also have that the sum of any two of them multiplied together, so we can write it as the sum of alpha to the 8, beta to the 8 is equal to 5. And so we can quickly get S16 just by using algebra. So S8 squared is equal to S16 plus 2 times the sum of alpha to the 8, beta to the 8. Just in case you're getting a bit stuck with what's going on there, I'll write it in full. So the sum of alpha to the 8 squared is equal to, well, the sum of alpha to the 8 squared, and then just plus 2 times the sum of alpha to the 8 beta to the 8. So it's the same as what we normally do, I'm just writing it slightly different for convenience. So this is the sum of alpha to the 16, which just means alpha to the 16 plus beta to the 16 plus gamma to the 16. Alright, anyway, so we know that S8 is 10, so 100 is equal to S16 plus 2 times 5, so plus 10. So that means that S16 is equal to 90. And lastly, we just got to find S12. How do we do that? We can't do what we were doing before. Well, one way to go about it, and I think probably the easiest way, is this equation here. And, well, remember, this is an equation, and it has roots, alpha to the 4, beta to the 4, gamma to the 4, which means the value alpha to the 4 makes this equation true. So let's go and deal with that. So substituting the roots, alpha to the 4, beta to the 4, and gamma to the 4, into this cubic equation, we get alpha to the 12 minus 2 times alpha to the 8 minus 3 times alpha to the 4 minus 1 equals 0, and the same for beta and gamma. So beta to the 12 minus 2 times beta to the 8 minus 3 times beta to the 4 minus 1 equals 0, and gamma to the 12 minus 2 times gamma to the 8 minus 3 times gamma to the 4 minus 1 equals 0. And then from here, we can add them all together and make the following observation. Alpha to the 12 plus beta to the 12 plus gamma to the 12 is the thing we're looking for. That's S12 minus 2 times, well, S8. Because that's alpha to the 8 plus beta to the 8 plus gamma to the 8. Minus 3 times S4, and then minus 1, minus 1, minus 1, so minus 3. And that should equal 0. And then if we scroll back up, we calculated that S8 was equal to 10, and S4 was equal to 2. S8 equals 10, S4 equals 2. So then we have S12 minus 20 minus 6 minus 3 equals 0. And so S12 equals 29.